Let's talk about the next problem in motion in a plane. This one is about relative velocity. This problem is a typical Rain Man problem that students may have encountered multiple times. The problem here is a very simple one that says rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in north to south direction. So she's going towards the south direction. What is the direction in which she should hold her umbrella? The problem is very straightforward. First of all, we'll try and visualize how the entire motion looks from a ground frame and when we are ground observers. Then we'll move into the frame of the woman and then we'll again visualize the problem. So over here, first of all, we are the ground observers and the rain is falling vertically down. The sign convention that we have chosen for this problem is south direction is positive, north is negative, up is positive and down is negative. So all the vectors in these directions will be given the respective signs. We have also taken south as the I cap direction, north as the minus I cap, up as the j cap direction and down as the minus j cap. So if the rain falls down with a velocity 30 meters per second, its velocity in vector form can be written as minus 30 j cap meters per second. The woman is driving towards south, so her velocity can be written as 10 I cap meters per second. This is what we observe as the ground frame observers. So clearly these two things are very clear to you. Velocity of woman VW is 10 I cap meters per second and velocity of rain with respect to ground is VR or VR vector, that is minus 30 j cap meters per second. Now if I have to calculate velocity of rain with respect to woman, or in other words, how does woman see the rain coming towards her? I can write velocity of rain with respect to woman is simply velocity of rain minus velocity of woman. That is the most fundamental formula for relative velocity. So this can be written as minus 30 j cap because that's the velocity of rain, minus of plus 10 I cap because plus 10 I cap is the velocity of woman. So upon expanding it, we get minus 10 I cap plus 30 j cap meters per second. So the woman will perceive the velocity of rain to be this one. So if we try and visualize how this will look like, it will look something like this from the frame of the woman. So clearly here, because woman is the observer herself, so she feels that she is at rest and the entire world is moving with respect to her. And the rain will be coming with a velocity minus of 10 I cap plus 30 j cap meters per second. So it's falling down and also turning a little backwards in the I cap direction, because if I open the bracket, it will be minus 10 I cap minus 30 j cap. So the rain is somewhat in the I cap direction, minus I cap direction and somewhat in the minus j cap direction. So if I take that into account, the rain essentially appears to her like this. So if she really has to hold her umbrella, it should be exactly opposite to the direction of rain if she does not want to get wet. So if we calculate for this specific condition, we take one stream of rain falling. The rain is falling like this and it is 30 in minus j cap direction and 10 in minus I cap direction. And I'm interested in calculating this angle theta as to at what angle the woman should hold her umbrella. So clearly this angle theta can be calculated as tan theta is equal to 10 upon 30 from this triangle directly, and this can be written as 1 by 3. So theta is simply tan inverse of 1 by 3. So the angle that the rain is falling from vertical with respect to the woman is at tan inverse 1 by 3. So at what angle will the woman hold the umbrella? The woman must hold the umbrella exactly opposite, something like this, and you can see she also has to hold the umbrella at an angle theta with the vertical. You can directly see from the diagram. So I can say that the angle the woman should hold her umbrella with respect to vertical is simply equal to tan inverse of 1 by 3. This is our answer for this problem. I hope you have understood the method how to tackle a typical Rain Man problem. Thank you.